Alright, hello and welcome back to the last video of part D of, this unit. And we're going to be talking about the last postulate, which is the angle side postulate, AAS. And as I was reviewing the last video, I noticed that I called this the angle side angle, or this SAS. I meant to say ASA, so sorry about that. But here, AAS, the angle side postulate. So let's give this the definition. So if two angles and the non-included side of one triangle are congruent, with two angles and the non-included side of another, then the two are congruent. I guess I should be saying that then the two triangles are congruent. Okay. So to kind of show what this means, so again, so in the past videos we've been talking a lot about the included side. So if we have two triangles, okay, so we said that the two angles, so let's say we had these two angles and the non-included side. The non-included side, which would mean, it could mean this one right here, that's a non-included side. So this would be an angle, and a side, an angle, and a side. Or you could have these two angles and this side right here, which is the non-included side, right? Just as long if it's not the included side. But in any case, this theorem, the angle side, states that that if you have two triangles, and they have congruent angles, and the non-included side of those two angles, if these are congruent, then the two triangles are congruent. So in this diagram, angle BCA, so this angle right here, BCA, is congruent with angle DCA. Which sides are congruent? So those two are, those two angles are congruent. We also know that these two right here, that this side right here, so AC is congruent with AC, right? So AC is congruent with AC, and I know that because it's a reflective property. So those sides are congruent, and that's pretty much all that we could really say at the moment. Those are the only sides that we know for sure are congruent. We don't know if BC is congruent with CD. We don't know if AB is congruent with AD. We don't know. Okay. So which additional pairs of corresponding parts would need to be congruent for the angles to be congruent by the AAS theorem? So angle side. So that would mean, so the other parts to be congruent would have to probably be this angle right here. So angle B and angle D would have to be congruent to give us an angle, side, an angle, and a side. Okay. So angle B would have to be congruent with angle D. Okay, if this were going to be congruent by the angle side, and I'm pretty sure that that's the only way that it could be. So, and sorry, this is just a repeat of a statement, so you can ignore that. But let's do an example where we have to use the angle side theorem. Okay, so in here we are given that angle S is congruent with U. So I know that this angle is congruent with this angle. Alright, and then it's also given that TR, so this line right here, bisects the angle STU. STU, which is this angle right here. So that angle is bisected by TR. So that means that I know right away that this angle right here and this angle right here are congruent, because that's by definition of a bisector. Okay, so I know that angle STR is congruent with angle UTR because of bisector. And then TR, so I know that those two are congruent, which leads me to know, so I know that this angle is congruent with this angle right there, and so I'm trying to prove using angle side angle. Okay, so angle angle side. Okay, so angle side. So here's an angle, and it has to be the non-included side. So that means this right here is the non-included side. So can we prove that TR is congruent with TR? And yes, we can. We can prove that TR is congruent with TR because of the reflective property. Okay, and so because we know that, that means that triangle SRT is congruent with triangle URT are congruent. These are congruent because we have an angle, and a side that is congruent with an angle, and a side of two different triangles. So that's the angle side postulate. Now, were we trying to prove that the two triangles were congruent? And the answer is no. We were trying to prove that SRT, so we're trying to prove that SRT, so this angle right here, is congruent with this angle right here, URT. Now, we know that the two triangles are congruent, and so, because the two triangles are congruent, then I know that angle SRT is congruent with URT, because these are corresponding angles of two different triangles, and so by the corresponding parts of congruent triangles are congruent postulate, we know that that's why these are congruent, because the two triangles are congruent, so that means their corresponding parts are congruent. Okay, so there's an example there. Also, I kind of just realized that these are not the same statements. This says angle side angle, and this says angle side. So if you wanted to go back and review this for this part right here, go for it. But to end this video, I just wanted to quickly go through right here these statements right here. Now we've gone through, if we want to review really quickly, SSS, which is side side side, SAS, which is side angle side, ASA, which is angle side angle, and then AAS, okay, which is angle side. Those, using these parts, we can prove congruence between two triangles. Now these right here, so side side angle and angle, does not prove congruence. Do not prove congruence. So remember that. Side-side angle and an angle, there's no postulate which says that these prove congruence, okay? So just remember that. So if you ever find yourself trying to write side-side angle or angle, or if you look at it this way, if you go this letter to this letter to this letter backwards, which I'm not going to spell out on video because it'd be inappropriate, but in any case, don't do either of those because these do not prove congruence, okay? So, hopefully this video you found interesting, and that you make sure that you memorize at least the order of these letters so that you can use them to prove congruence of triangles. So email me if you got any questions, and I'll see you in class.